Solving two-step equations. So two-step equations are called two-step equations because you can solve them in two steps. Usually, in a two-step equation, we're not going to have to distribute, we're not going to have to combine like terms. We're going to drop right down to steps 4 and 5 in the problem-solving process. So the first thing we're going to have to do is use the addition or subtraction property to move the constant term to one side. And then we're going to use the multiplication or division property to get a coefficient of 1 on the variable. So in this first problem, it says 2n minus 5 equals 3. Well, the first thing I would do, of course, is step 1. And that's just to change subtraction to addition of the opposite sign. So we get 2n plus negative 5 equals 3. Now, to get rid of a negative 5, we just add 5. So we're going to add 5 to both sides. Negative 5 plus 5 cancels. And we're left with 2n equals, and then 3 plus 5 is 8. Now we have 2 times n equals 8. So we want to get rid of this multiplication of 2, so we divide by 2. 2 divided by 2 is 1, so we get 1n, which is just n, equals 8 divided by 2 is 4. Alright, so you might have noticed at the top, when I did step 1, changing subtraction to addition of the opposite, that we really could have just added 5, because addition is the opposite of subtraction. But in the beginning, I would highly suggest that anytime you see subtraction, you just change it to addition of the opposite. As you get better at equation solving, then you'll start to learn when it's really beneficial to change subtraction to addition of the opposite and when it's unnecessary. But for the time being, let's just always do it. In our second equation, we have negative 16 equals t divided by 4 minus 14. So the first thing is to change subtraction to addition of the opposite. So we have minus 16, or negative 16, equals t divided by 4. And then instead of minus 14, we're going to write this as plus negative 14. Now, remember, the first thing you want to do is isolate the term with the variable in it. And the term with the variable in it is t divided by 4. So we'd like that t divided by 4 all by itself. And we do that by getting rid of the negative 14. To cancel a negative 14, I have to add 14. Remember that whatever I do to one side, I have to do the exact same thing to the other side. So negative 14 plus 14 cancels, and we're left with just t divided by 4 on that side. Negative 16 plus 14 gives us negative 2. So now we have t divided by 4. And our goal is to isolate that t. So to get rid of the division of 4, we have to multiply by 4 on both sides. Division by 4 and multiplication by 4 cancel. So we're left with just t on that side. And 4 times negative 2 is negative 8. So we have negative 8 equals t, or t equals negative 8. In our third equation, we have negative 4 equals negative 3p plus 14. Well, we don't have any subtraction to change to addition of the opposite, so we can get started Looking at the p, it's negative 3p plus 14. So the first thing we want to do is isolate the negative 3p, which means we want to get rid of the 14, so we subtract 14. Minus 14 is 0, so that term cancels. And we're left with negative 3p. Negative 4 minus 14 is negative 18. So we've got negative 3p equals negative 18. So remember that negative 3p means negative 3 times p. And to get rid of a multiplication of negative 3, I need to divide by negative 3. Negative 3 divided by negative 3 is 1. So we're left with 1p, which is just p. Negative 18 divided by negative 3 equals positive 6. Now, anytime we're done with a problem set, I would strongly suggest checking. So let's go back to the top and let's check. In the first equation, we said that n should equal 4. So if I take 2n minus 5 equals 3, to check, first I replace my variable with a set of empty parentheses. Now, I plug in 4 for n. And just follow the order of operations. So 2 times 4 is 8 minus 5 equals 3. And 8 minus 5 is 3. So we get 3 equals 3, which checks. One thing I want to point out is that we have calculators. So although I'm doing this step by step, we could simply plug in 2 parenthesis 4 parenthesis minus 5 and just make sure that we get 3 equals 3 at the end. So to check the next one, in our second equation we said that t should equal negative 8. So we take our equation, negative 16 equals t divided by 4 minus 14. We're going to replace our variable with a set of empty parentheses. So negative 16 equals our t divided by 4 minus 14. And inside our empty parentheses, we're going to plug in our solution for t, which was negative 8. So that gives us negative 16 equals negative 8 divided by 4 is negative 2 minus 14. Well, remember, subtraction, we changed to addition of the opposite. So minus 14, we're going to change to plus negative 14. And negative 2 plus negative 14 is negative 16. So we get negative 16 equals negative 16, which is true. So our answer checks. Finally, we're going to check our third one. And we said that p should equal 6. Our equation was negative 4 equals negative 3p plus 14. Replace our variable with a set of empty parentheses. And inside that empty parentheses, we plug in our solution. P equals 6, so we plug in 6. So we get negative 4 equals negative 3 times 6, which is negative 18, plus 14. So negative 4 equals negative 18 plus 14 is negative 4. And our answer checks. So remember, you don't have to do these all by hand. What I would suggest doing is, like in the second one, once you plug in the negative 8, just plug in the right-hand side, negative 8 divided by 4 minus 14, and make sure that you get negative 16. That will tell you your answer is correct. In number 3, we would plug in the left-hand side, negative 3 parenthesis 6 parenthesis plus 14, and just make sure that we get negative 4.